already seen problems up to 2 set. Let's talk about bit strings. Okay, so your task is to calculate the number of bit string of the length n. For example, if n is equal to 3, so you have to calculate all the possible strings of length 3, right? All the possible bit strings. So there are 8 actually for 3, which means like from 0 to 2 raised to the power 3, you have to uh, get all the bit strings. So you don't have to print the bit string, you just need to return the number of bit string. So for n, the answer is 2 raised to the power n. So you're given an input integer n. What you need to return is basically 2 raised to the power n. But you can't directly do it because n can be huge up to 10 is power 6. So when this number processed as a power of 2, it's a huge. So we do modular mathematics. So modular, we call it modular power function or something like binary power function, right? If you search about that, that is basically a very standard thing when you have to implement a power function with using modulus continuously. So it has a function like, if I, yeah, now let's talk about the logic. So you pass your base, you pass your exponent, you pass your modulus to the binary power function or something like modulus power function. Then it is based on the, let's say, fast power. First of all, you need fast power. One thing is that because the number is huge, okay, and that because the number is huge, you need fast power, and because the number is huge, the power can become huge, and then you need modulus as well. So these two things go side by side. So the logic for fast power is that your base, like the number of multiplications, you reduce your number of multiplications, and instead what you do is basically you keep on increasing the uh, yeah, base, not base, but the, you keep on reducing your exponent and yeah, increasing your base. So for example, I need to calculate 2 raised to the power 8. What I do is my base is equal to 2, exponent is 8. So I go like, whenever my exponent is odd, then I will multiply my base into result. But what happens, okay, 2 raised to the power 8 will be written as 4 raised to the power 3, 4 is to the power 2, sorry. So 8 gets divided by 2, that becomes 4, and that 2 like basically base getting multiplied by itself. So it's 4 raised to the power 4. 2 raised to the power 8 is equal to 4 raised to the power 4, something like that. And then you again multiply base by itself and reduce power by 2. So 8 raised to the power 2, okay, 2 raised to the power 8 becomes, sorry, base multiplied by itself, 16 raised to the power 2. Yeah, that's fine. 16 raised to the power 2. Now again you see that base has to be divided by, sorry, exponent has to be divided by 2, and base has to be like multiplied by 2. So 16 becomes 16 square, which is whatever. Yeah, then after that 256 now, yeah. And then your exponent is equal to 1. Whenever your exponent becomes odd, you multiply that into result. I think that's a pretty standard thing which I just said. Let me show you my code, or let me implement this also. Print n, scene n, what you need is 2 raised to the power n. So basically I can just say that, okay, but let's talk about a general power function. So it has a base, it has an exponent, it has a modular mod. Then you have int r equal to 1. We have while your exponent exists. Then you have exponent mod 2. Then basically you say r is equal to r into base, and exponent divided by 2 every time. Base is equal to base into base square every time. Now you return r, and we have mod. We use this mod. That is fine and that should be fine. The base is n, base is 2, exponent is actually n, and modulus. So let me pass something like 6. It should give me 2 raised power 6 here. I think we can directly put it. Yeah, if I put 16, that should give me 2 raised power 16. That is also huge, and that is correct. Now or you can just check the summation. There I want to do it without long onwards. Let's choose file, and we have over here. I can create it as a bit string too. Yep, let's see. Modular multiplications or something. Yeah, modular things needs to be taken care. What we can do more cautiously about mod. I think first of all, this can help a lot. Okay, for that. Then you have the sign. Let's take it here. Save it all. Save. And as I said, 256 is something they have passed on. Let's see. What will be 2 raised to the power 256? At least it is giving me something. I think it is fine to submit now. So int में तो नहीं चला long now होनी चाहिए at least. But your final answer is going to be integer. We need long for like calculation inside it. Yep. So whenever these two things are being multiplied, r mod mod into b mod mod, this can go integer overflow. So for that, what you will need ki yeah, b को long long बना लो individually, r को long long बना लो, but the output in the end you will get is integer range only. That will not overflow. Sure. So let's talk about the next question, trailing zeros. This is also a very good problem, and in this you have been given a number n. You need to calculate the number of trailing zeros in n factorial. Okay, before solving this, like again, I need to remind you that yeah, like factorial is something which is 1 into 2 into 3 till n, and you have to print the trailing zeros in an effect. Well, how does zero come up in effect? Something like, yeah, product of any numbers. So you got 1 5 and 1 2, that makes up to 1 0. So you see how many, yeah, twos are there and how many fives are there, and take minimum of that. So how do you get how many twos are there? So every second number contributes at least one two. Why I'm saying at least, you will get it. So 2 contributes like 1 2, 4 contributes 2 twos, 6 contributes again 1 2, 8 contributes 3 twos. Then you have 10 which contributes single 2, 12 contributes 2 2, and yeah, 14 contributes something like 2, and 16 contribute 4 twos. Okay, so yeah, that's how the numbers are. Now let's talk about 5. So 5 contributes single 5, 10 contributes a 5, 15 contributes a 5, 20 contributes a 5, yeah, just a single 5. 25 actually contributes two fives because it has 5 into 5, you know, as 25 is made up of 5 into 5. So what I'm saying, have to know about what will be there in 20 factorial trailing zeros, how many factors of 2 you got. Count this, like 1 you got from 2, 2 you got from 4, 1 you got from 6, 3 you got from 8. So just add up these numbers, like 1 plus 2 plus 1 plus 3 plus 1 plus 2 plus 3, and so on, like that. You need to calculate it so that you get, okay, these are so many number of twos. It's not just like 20 divided by 2, so that like not every second number contributes a single two. Sometimes they contribute more twos as well. So that is not limited to 20 divided by 2. Similarly, in 5, uh, here, like no one contributes more than a single 5. So everyone contributes a single 5. So 20 divided by 5, you can say there are 4 elements as that happens. And that's why the answer is 4, minimum of that. Now, how do you get this now? How do you get that? This will contain like, so what we do, we just go over each power of 2 and see the logic is like that. Ki you start from 2 and then you go for 4, then you go for 8. So 2 के कितने multiples would be there in 20? 20 divided by 2, 10 multiples of 2 would be there, sure. 4 के कितने multiple होंगे? 20 divided by 4, 5 multiples, like 4, 8, 16 and 20 itself. So ये चार number, or 12b actually. So yeah, this is total 5. These 5 numbers will contribute 2 twos. तो इनका एक और एडिशन आएगा, ठीक है? एक तो 2 मैंने ऑलरेडी ले लिया है, बट एक और एडिशन आएगा। एंड कितने ऐसे नंबर है जो 3 टूज कंट्रीब्यूट कर रहे हैं, ठीक है? 8, 16, these are the two numbers. तो इन दोनों को भी मेरे को एक एक्स्ट्रा काउंट करना पड़ेगा, बिकॉज इनका 2 कंट्रीब्यूशन तो मैंने ले लिया है। बिकॉज जो 3 कंट्रीब्यूट कर रहा है वो 2 भी कंट्रीब्यूट कर रहा होगा उसने, तो वो ऑलरेडी काउंट हो चुका है, और सिंगल भी काउंट करा हो चुका है उसका। तो ये नंबर 3 बार क्यों लिखा गया, लाइक 8 3 बार क्यों लिखा गया? एक बार जब ये 20 डिवाइड बाई 2 की फॉर्म में आया तब 8 लिखा गया, एक बार ये 20 डिवाइड बाई 5 की फॉर्म में आया, सॉरी 4 की फॉर्म में आया, तब ये एक बार काउंट हुआ कि 4 के डिवाइजर्स में 8 का नाम आया। फिर 20 डिवाइड बाई 8 के डिवाइजर्स में भी एक बार 8 आया, एक बार 16 आया, बिकॉज 8 भी 3 बार आया अभी और 16 भी 3 बार आया, बिकॉज ये 3 कंट्रीब्यूट कर रहे हैं, और 16 एक और बार आएगा जब वो 4 भी कंट्रीब्यूट कर रहा है, ठीक है? So this is how you have to just see how many contributions of 2 and 5 are there, and then return minimum of that. Let me code this also, because these two questions are good, and like you should be getting some of it. Like this is something standard which is used in variety of problems, so that I need to code that, like fast power function. This I need to code because of the, yeah, trick part of it. what you need to take just input c in n, and then what you need to do is just for I, you start off at a particular thing 2, you go till n plus 1, and then you say okay, over here you can have 2, but what my for function means you need to see it clearly. So defining a for ISE, it's not a difference, now it is a multiple. For int I is equal to s, I is less than e, I multiply equal to multiple. Okay, so this is what is happening. It's not just plus equal to, it's multiply equal to. And now you need to see basically c1 c2, you can also create c2 is equal to 0, c5 equal to 0. So c2 plus equal to n divided by I. Okay, similarly you go for number 5. This is 5, and every time it is multiplied by 5. C2 5 c5 plus equal to n divided by I. At last you have to minimum of print minimum of c2 comma c5. For 20 you can see what will be the answer. It will be 4. For 25 if you see, it would not be just 5, because okay, you have got 5 5, so it will be 6. Yeah, you got 1 5 extra, and obviously number of 2's are very large, like obviously different things. Just pick it, and I think I would have done similar summation, but yeah, I want to submit it as well. Long. Yep, so good. So far so good. So this was all about this. We did 2 questions. Now you need to tell this whether you should continue like this or you should do single question in our video. Okay guys, bye.